Imagine walking through a modern city, surrounded by skyscrapers, overpasses, and colossal bridges. Now, imagine that many of these techniques were already being used 2,000 years ago by the Romans. They didn't just build an empire with swords and legions, but with concrete, aqueducts, and roads that spanned continents. And the most impressive part? Many of these structures still exist, standing the test of time and even challenging modern engineering innovations. From the early days of the Republic, the Romans realized that infrastructure was key to power. No civilization before them had invested so much in building roads, bridges, aqueducts, and fortresses to consolidate their rule. But this evolution didn't happen overnight. In the beginning, Rome was just a modest city on the banks of the Tiber, with dirt roads and simple buildings. It was through a mix of innovation and learning from older civilizations like the Etruscans and Greeks that the Romans turned their city into an architectural powerhouse. Roman engineering was much more than a reflection of the technical genius of its builders. It was a political and military tool. A well-built road allowed the legions to march quickly to any point of the empire, quelling revolts and securing new conquests. Strategically positioned fortresses ensured control over provinces and protection against invaders. Aqueducts brought clean water to increasingly populated cities, ensuring public health and the well-being of the population. But how did a people who started with straw huts manage to erect monuments that defy time? The answer lay in the Roman obsession with planning, discipline, and their ability to learn from other cultures, adapting and perfecting their techniques. And above all, in the ingenuity of their builders, who were not just manual laborers, but visionaries capable of turning stone and mortar into symbols of power and durability. Among these visionaries were those responsible for one of the greatest feats in the history of engineering, the Roman roads. Far more than simple dirt paths, they were perfect channels of expansion and control, designed to last centuries. And their secret lay in meticulous construction, with a layered system that absorbed the impact of time and marching legions. But how did the Romans create a road network that connected every corner of the empire and can still be seen in various parts of the world today? Imagine an empire stretching from the Atlantic to the Middle East, covering thousands of miles. How was it possible to govern such a vast territory without modern means of communication and transportation? The answer was under the feet of every legionary, merchant, and traveler, the Roman roads. Built with impressive rigor, these roads were not simple dirt trails, but true masterpieces of engineering. Designed to withstand time, weather, and the constant weight of armies and carts, the Roman roads followed a meticulous construction pattern. First, engineers chose the best route, leveling the ground and ensuring the road was as straight as possible. Romans avoided unnecessary curves, preferring to cut through hills and build bridges when necessary. The foundation was reinforced with large stones, followed by layers of gravel, sand, and a special mix of lime and mortar, creating an incredibly durable surface. Additionally, the roads had a slight arch in the center, allowing rainwater to flow off to the sides, preventing erosion and flooding. This drainage system was so efficient that many of these roads still exist and are in use today. But these roads weren't just for facilitating travel. They were the backbone of Roman expansion. Whenever a new territory was conquered, a road was built, ensuring that troops could move quickly in case of revolts or invasions. All roads lead to Rome wasn't just a saying, it was a strategic reality. Besides the military aspect, the economic impact of these roads was immense. Merchants could transport goods more quickly and safely, connecting different parts of the empire and encouraging trade between diverse cultures. Cities that were once isolated became bustling centers of commerce. Exotic products from the east reached the western provinces, and grain from Egypt supplied Rome without difficulty. Milestones installed every Roman mile, approximately 1.5 kilometers, not only indicated distances and directions, but also served as a reminder of the empire's presence. Each one bore inscriptions with the name of the emperor under whose rule the road had been built, reinforcing Rome's authority over travelers on these roads. Thus, with stones fitted precisely, advanced drainage systems, and a long-term strategic vision, the Romans created a road network that connected the farthest provinces to the heart of the empire. But while the roads ensured troop movement and commerce, there was another essential innovation for urban life: the aqueducts. How did the Romans transport pure water over hundreds of miles to their cities? Imagine a city with over 1 million inhabitants, without access to nearby rivers or abundant lakes. How could they ensure potable water for drinking, cooking, bathing, and keeping the famous Roman baths in operation? This was a vital issue for Rome and its provinces. The answer came with one of the greatest feats of ancient engineering, the aqueducts. These impressive structures allowed the Romans to transport water from distant springs to their cities, ensuring a continuous and reliable supply. Before them, other civilizations like the Greeks and Persians had experimented with rudimentary systems of channels and underground pipes, but it was the Romans who took this technique to an unprecedented level. The construction of an aqueduct began with a detailed analysis of the terrain. Roman surveyors used advanced tools like the groma and dioptra to calculate the ideal slope. The incline needed to be precise enough for the water to flow naturally, without the need for pumps or external force. If the slope was too steep, the current would be too strong and could damage the structure. If it was too shallow, the water wouldn't reach its destination. This millimetric balance is one of the factors that make Roman aqueducts so impressive. To cover large distances, engineers combined underground tunnels and elevated channels. When they encountered valleys or rugged terrain, they built the iconic stone arches, some reaching tens of meters in height. One of the most spectacular examples of this technique is the Pont du Gard in present-day France, a monumental structure that still impresses with its size and precision. The water that reached the cities was distributed through a complex system of pipes, cisterns, and public fountains. The baths, communal baths that became one of the symbols of Roman lifestyle, directly relied on this constant supply. But the aqueducts weren't just about comfort, they also played a key role in public health. By ensuring clean water for the population and maintaining waste drainage, they helped reduce the spread of disease. Maintaining this massive infrastructure required strict administration. Specialized engineers, known as aquari, were responsible for overseeing maintenance, preventing leaks, and ensuring water distribution was efficient. Additionally, Rome had to deal with another issue: illegal water use. Many citizens tried to divert the flow for their own benefit, which led to strict oversight by the authorities. The efficiency of this system was so great that some of these structures remained in use for centuries, even after the fall of the Roman Empire. Some European cities still use sections of these ancient aqueducts for water supply. But keeping cities well supplied was not enough. Rome also needed to protect them. And for this, they relied on another great engineering achievement: their walls and fortifications. How did the Romans build some of the most formidable defenses of antiquity? Throughout their expansion, Rome faced constant challenges. As the empire grew, the need to protect its borders and conquered territories became increasingly crucial. The solution to this problem wasn't limited to brave soldiers or unbeatable armies. The Romans, masters of engineering, built fortifications and walls that not only defended, but also symbolized Rome's immense power. One of the most notable walls is Hadrian's Wall, which stretches over 120 kilometers along northern Britain. Built in the 2nd century AD, it was designed to mark the boundary of Roman lands on the island and protect against barbarian tribes like the Picts. Made of stone and with a system of ditches and trenches, the wall was not just a physical barrier, but also a demonstration of Roman authority, a reminder that Rome was always in control. But Roman walls weren't just large and imposing, they were also strategically planned. The Limes Line, stretching across the empire from Germany to the Middle East, was a series of fortifications and outposts connected by roads and aqueducts. These fortifications ranged from simple wooden bastions to complex stone fortresses. Each one was designed to operate independently, with its own garrison and defense systems, but also to integrate into the empire's larger defense network. Within these walls and fortifications, the Roman legions were trained not only for battle, but also for construction. During military campaigns, Roman engineers could quickly erect fortified camps, protecting the troops and providing vital infrastructure for the campaign. These camps were designed to be set up and dismantled with impressive speed. A Roman camp was not just a temporary shelter, but a small city with organized streets, protective ditches, and even bathrooms and storage facilities. The symbolism of these constructions was also key. The grandeur and complexity of Roman fortifications not only guaranteed security, but also sent a clear message. Rome was invincible. Hadrian's Wall, for instance, was more than physical protection. It represented Roman dominance over its territories and the end of the wild, untamed frontier. Every stone placed in the walls was an affirmation that Rome was here to stay. But just as civil engineering and road building were crucial to the empire's growth, another aspect was vital to its stability: the training and specialization of its soldiers. How did the Romans transform their soldiers into engineers and master builders throughout their campaigns? The answer lay in the unique concept of military engineering. When we think of Roman legionaries, it's easy to imagine tough warriors, marching with swords and shields, ready to conquer distant lands. But what many don't know is that, beyond their combat skills, these soldiers were also specialists in another field essential to the empire's success: engineering. Initially, Roman legionaries were trained only to fight. However, as campaigns expanded, it became clear that the rapid construction of fortifications, bridges, and other infrastructures would be vital to military success. Rome not only conquered territories, but also needed to ensure these territories stayed under control. To do so, mastering not only the art of combat, but also the art of construction was necessary. The legionaries' adaptation to this new role began when Rome incorporated the figure of the military engineer into its legions. These engineer soldiers, known as immunes, were promoted to a special status. While they continued to serve in combat ranks, they received additional training in construction and engineering techniques. The position of immune was not just a privilege, it reflected recognition of the soldier's special skills. Being immune meant being exempt from common tasks like sentry duty or routine work, allowing them to focus on building and maintaining military engineering feats. These engineer soldiers were versatile. In a campaign, they could be tasked with erecting fortified camps overnight, designing temporary bridges to cross rivers, and even building complex siege structures like siege towers and catapults, which were used to breach enemy cities. Their ability to quickly and efficiently build fortifications and other structures could be the difference between success and failure in battle. One of the greatest achievements of Roman engineer soldiers was their ability to build mobile bridges during military campaigns. These bridges were essential for the legions to cross rivers quickly and without delay. A famous example of this was Julius Caesar's crossing of the Rhine during his campaigns in Gaul. Using planks and wooden posts, the engineer soldiers built a sturdy bridge in just 10 days, allowing their troops to cross the river and surprise the enemy. But engineer soldiers weren't just skilled at building temporary structures. They were also crucial in creating permanent structures, such as fortifications and defensive walls, which protected the empire's borders. As Rome expanded into distant lands, these fortifications played a vital role in securing the provinces, creating a complex and impenetrable defense system. Thus, Roman military engineering evolved from a secondary skill to an essential discipline for the empire's success. The legions weren't just made up of soldiers, but of true engineers who helped shape the empire, making it stronger and more resilient with each battle won. And the training of these engineers, which mixed military practice with technical knowledge, made them some of the most specialized professionals in ancient history. But the Roman skill in construction and planning wasn't limited to military engineers. They also knew that the true strength of an empire depended on its civil infrastructure. How did the Romans train their civil engineers? And what techniques did they use to expand and manage their vast territory? If Roman engineers were known for their monumental constructions, the foundation for these feats lay in a rigorous and highly specialized training. The education of engineers was no simple task. It combined practical and theoretical knowledge, creating a generation of professionals capable of dealing with immense challenges. The training of a Roman engineer began with a focus on military disciplines. Since the Romans believed in discipline and teamwork, many military engineers came from the legions. These engineer soldiers were instructed in a variety of skills, from surveying terrain to building fortifications. The training of an immune military engineer included a significant portion of geometry, surveying, and construction, as well as learning how to operate war machines. This preparation was essential, as they needed to be able to design and build quickly without losing focus on military objectives. At the same time, a growing number of civil engineers emerged in Roman cities, trained in specialized schools. These professionals were involved in constructing large public works, such as aqueducts, roads, bridges, and drainage systems. Their training focused more on the practical application of geometric and civil engineering theories, with an emphasis on using materials such as stone, cement, and concrete. Geometry was crucial for planning and executing these constructions, as it allowed precise calculations of dimensions, distances, and levels. The Romans had a unique approach to practical training. It wasn't enough for engineers to simply know how to draw or design. They needed to know how to put their ideas into practice. One of the most important tools for this was the groma, a surveying instrument used to draw straight lines and measure angles, which was essential in planning roads and building aqueducts. Another crucial instrument was the dioptra, used to measure distances and angles precisely, especially useful in mapping terrain and surveying structures. Alongside their technical training, Roman engineers also underwent military training. They were expected to know how to behave on the battlefield, manage resources during campaigns, and apply their knowledge in wartime situations. For road engineers, this meant being able not only to plan and build roads, but also to quickly construct fortifications and defenses to protect troops during military campaigns. This combination of technical, military, and practical training is what made Roman engineers so exceptional. They were not just scholars or builders, they were also strategists, capable of facing any challenge, whether in warfare or in building an empire. However, training didn't stop at the basics. Roman engineers were constantly challenged and refined as the empire's needs evolved. As Rome expanded and its borders became more complex, new demands emerged, requiring more sophisticated techniques. How did the Romans evolve to meet these demands, adapting their techniques and expanding their construction repertoire? As the Roman legions advanced through the vast lands of the empire, a key factor in the success of their campaigns was the ability to quickly build essential structures for the army. The Roman strategy of integrating engineers directly into the legions transformed the way the empire conquered and defended its territories. These engineers were not just specialized professionals, but soldiers who marched with the troops and were ready to act immediately in any wartime scenario. Field engineers were essential members of the legion. When the order was given to march, the engineers moved with the soldiers, ready to build bridges, camps, and fortifications while the troops headed to their next destination. The speed with which these structures were erected was a direct reflection of Roman military training and discipline. While the legions prepared for battle, the engineering units began working on constructing temporary camps. These camps were not just makeshift tents, but complete and well-structured installations designed to house hundreds or even thousands of soldiers. These fortified camps were true temporary strongholds, with moats, wooden walls, and watchtowers. The intense training of Roman engineers allowed these fortifications to be set up in record time, protecting the troops at night and creating a safe space for storing supplies and ammunition. Every component of the camp was designed to be assembled and dismantled quickly, allowing the legions to move nimbly and safely. In addition to camps, Roman engineers were also responsible for temporary bridges. When the troops needed to cross rivers or other natural obstacles, the engineers built makeshift bridges using local materials, such as wood and rope. A notable example of this occurred during Julius Caesar's campaigns. When he crossed the Rhine to face the Germans, his legion built a wooden bridge in just 10 days, an impressive feat of military engineering. These bridges allowed the legions to move quickly and attack the enemy without being delayed by natural obstacles. But the engineers were not limited to building camps and bridges. They were also responsible for maintaining the roads used by the legions. Roman roads were essential for the rapid movement of troops and the transport of supplies. When a road was damaged in battle or by the weather, the field engineers quickly took charge and made the necessary repairs, ensuring that the army's logistics were not compromised. However, this integration of engineers and soldiers wasn't just a practical matter. It also reflected Rome's philosophy, the ability to adapt and efficiently utilize all available resources. By being integrated directly into the legions, the engineers became full-fledged soldiers with the ability to build, defend, and attack, all in one move. This flexibility allowed Rome to maintain a strategic advantage over its enemies, because while its adversaries fought with conventional military forces, Rome was already one step ahead, building its own path to victory. This integrated engineering approach was one of the keys to Rome's military success. However, as the empire expanded and its borders grew, recruiting experienced engineers became even more crucial for the empire's functioning. How did Rome manage to attract the best specialists to its military ranks? And what role did master civil builders play in this process? As the Roman Empire expanded, there was an increasing demand for engineering specialists. Complex projects such as roads, bridges, aqueducts, and fortifications required technical skills beyond what ordinary soldiers could provide. Therefore, Rome sought master builders, highly trained professionals with expertise in architecture, hydraulic engineering, and urban planning, to oversee and coordinate the construction of these large structures. These civil engineers were recruited based on their exceptional skills and experience with monumental works. Many came from newly conquered regions, bringing with them new approaches and techniques that Rome could adapt to its own style of construction. Once incorporated into the army, these masters became part of a specialized workforce, vital to the expansion and maintenance of Roman infrastructure. In exchange for their expertise, civil engineers received substantial benefits. In addition to tax exemptions, these professionals were often rewarded with land or elevated status within Roman society. More than just a transactional exchange, their work was seen as a strategic contribution to the glory of the empire, something that could secure their social promotion and prestige. However, the work of these master builders went beyond construction itself. They were also responsible for managing materials and resources, ensuring that projects progressed efficiently and without setbacks. From choosing the right materials, such as stone, brick, and wood, to coordinating work teams, civil engineers were essential to the successful execution of monumental projects. In the case of aqueducts, for example, the engineer not only designed the structural plan, but also organized the extraction of stone and coordinated the logistics of transporting materials to the construction site. Additionally, these engineers were often called upon to supervise the training of new workers, ensuring that Roman construction techniques were passed down from generation to generation. The educational process was structured in such a way that the engineer led the projects, often with the support of soldiers and civilian workers who operated under their guidance. This complementarity between civil engineers and soldiers ensured that Rome's grand works were carried out with impressive technical precision. The example of Roman roads, for instance, shows how master builders and military engineers worked together to construct the roads that connected all regions of the empire, using advanced techniques in paving and drainage. Master builders also played a vital role in maintaining existing structures. An aqueduct or bridge required regular inspections and repairs, as any failure could cause irreparable damage. For this reason, their function went beyond just initial construction. It extended to the continuous monitoring of structures, making this group of specialists indispensable for the longevity of the Roman Empire. These civil engineers didn't just build the infrastructure of Rome, but they also became symbols of imperial power, reflecting Rome's commitment to permanence and control over its vast territory. What made this recruitment process so efficient and essential to Rome's success? How did these master builders directly impact the empire's conquests and maintenance? Behind the grandeur of Rome, a group of engineers played a fundamental and often invisible role. The aquarii, specialists dedicated to the construction and maintenance of the water systems that supplied the vast capital and its cities. These masters of hydraulic engineering were responsible for ensuring that Romans had constant and reliable access to water, a vital resource for daily life, especially in a city as populous and growing as Rome. Their expertise didn't only include the construction of aqueducts, but also the distribution and control of water through a sophisticated network of reservoirs, cisterns, and dams. Water wasn't just a utilitarian resource, it was a symbol of imperial power. To ensure the prosperity of Roman cities, the aquarii designed complex systems to transport water from distant sources, ensuring it reached efficiently and uninterrupted to public baths, fountains, domestic supply sources, and even imperial palaces. The skill of these hydraulic masters was undeniable. Using advanced engineering techniques for the time, they were able to build elevated arches that allowed water to be transported over long distances, even in rugged terrain. Roman aqueducts, often made up of several levels of interconnected channels, were designed to maintain a constant slope, allowing water to flow naturally to its destination, without the use of pumps. This required precise control over geometry and meticulous attention to the details of the route, considering every curve and elevation in the terrain. But the work of the aquarii didn't stop once the aqueduct was finished. They were also responsible for the regular maintenance of these systems, which required meticulous inspections to prevent blockages, collapses, or leaks. Periodic cleaning of the channels and checking the condition of support structures were constant tasks to ensure the system's efficiency. This constant water management also extended to maintaining water quality, with filtration systems and techniques to prevent contamination during transport. These specialists not only built aqueducts, but they also managed the water resources of an entire city, making critical decisions about how water would be distributed among different neighborhoods and communities. The fact that Rome managed to stay supplied with drinking water, even as a constantly growing metropolis, is a testament to the advanced knowledge and organizational capability of these hydraulic masters. In an empire where efficiency and sustainability were crucial, the aquarii played a central role, ensuring that the eternal city never ran out of water. They were, without a doubt, the guardians of water, sustaining the vitality of Rome and its provinces with such an essential resource. And over the centuries, their legacy in hydraulic engineering still resonates, inspiring modern practices of water management and urban infrastructure. But how did Roman hydraulic engineering influence the development of modern cities? And what made the aquarii so essential to the lasting success of Rome? Rome, with its vastness and complexity, needed more than just engineers to ensure the water system's success. To efficiently control the flow of water and guarantee that every Roman neighborhood and fortress had access to what it needed, Rome appointed specialized administrators. Among them, none was as prominent as Frontinus, who was responsible for overseeing the aqueducts at the end of the 1st century AD. Frontinus was a distinguished public official, not only for his governing ability, but for his deep technical and organizational knowledge of Rome's hydraulic system. His work wasn't just about overseeing the operation of the aqueducts, but also ensuring that no one abused or diverted water resources. Water, to the Romans, was a strategic wealth, and control over it meant control over the city itself. One of his greatest contributions was his written work, De Aqueducta Urbis Romi, a detailed treatise on the Roman aqueduct system. Through this work, Frontinus not only documented the system's functioning, but also described the challenges faced in ensuring a continuous water supply. He shared with future administrators the need to constantly monitor the aqueducts, inspect the channels, and solve emerging problems, ranging from structural decay to identifying illegal water diversions. Frontinus's work was of immense importance, as he instituted a rigorous control system, monitoring water with mathematical precision to prevent waste. His system of regular inspections and mapping the aqueduct lines helped identify any diversion or sabotage, such as water theft or illegal distribution practices. For him, transparency and fairness in water supply were paramount, and diverting resources wasn't just a crime, but an act that weakened the city's very structure. Additionally, Frontinus also established rules to ensure the continuous maintenance of the aqueducts was done efficiently. He managed the collection of water taxes, which were allocated to the maintenance and expansion of the hydraulic systems. His role also included managing emergencies, like droughts or unforeseen problems, where the ability to ration water became a vital factor for the welfare of the Romans. Despite his rigorous management, Frontinus was also known for his concern for social justice, something innovative for an empire that often prioritized control over the population. He ensured that the waters of the aqueducts were distributed in a way that served both the upper classes and the humbler populations, making sure public baths, fountains, and reservoirs remained open for the benefit of all. He believed that water shouldn't be a luxury exclusive to a privileged class, but a resource accessible to all citizens. Ultimately, Frontinus's work in overseeing the aqueducts not only ensured the continuity of the water flow to the city, but also strengthened Rome's image as a highly organized and efficient empire. His legacy as an administrator isn't limited to his practical actions. He was a visionary figure who understood that hydraulic infrastructure wasn't just a basic need, but a true backbone of the imperial city. What can Frontinus's approach to public resource management teach us? And how did he anticipate modern urban challenges? How do his techniques influence the handling of modern infrastructure? Roman land surveyors were the masters of territory. More than just land measurers, these professionals were responsible for planning and organizing the vast expanses of land that made up the empire, ensuring the empire's growth was sustainable and that each province was properly mapped and distributed. Their importance in Roman administration was immense, as Rome's success relied on meticulous and precise territorial planning. These engineers, surveyors, and topographers used sophisticated tools for their time, such as the groma and the dioptra, essential instruments for measuring and marking straight lines and precise angles. With the groma, for example, It was possible to trace long straight lines, crucial for building Roman roads and demarcating property boundaries and fields. The dioptra, on the other hand, helped measure distances and angles with a level of precision that seemed almost magical by ancient standards. These professionals were highly trained and often served in Roman legions, where they were responsible for marking and preparing land for the construction of fortresses, roads, and even new Roman colonies. Every conquered territory required a rigorous organizational process to ensure it was efficiently incorporated into the empire. Roads, military camps, cities, and agricultural properties had to be arranged in a way that Roman expansion was not only rapid, but also durable and structurally solid. Roman planning strategy went beyond simple land division. Surveyors helped create detailed maps that not only marked property boundaries, but also indicated soil conditions, available natural resources, and even water flows to ensure that construction was carried out in the most sustainable way possible. Each city, field, and fortress was designed to maximize resource use and ensure the land was easily accessible and defensible. These maps and drawings weren't just military or agricultural tools. They represented Roman dominion over nature, an effort to reshape the world around them and create a cohesive, functional infrastructure. A Roman surveyor's work didn't just involve measuring land, but also required a deep understanding of how the land related to the empire, creating harmonious structures between nature and human control. Additionally, the training of surveyors included knowledge of geometry and mathematics, which were considered essential for construction and planning work. The study of these disciplines was part of their technical education and ensured that the Romans could build not just large-scale structures but entire cities with perfectly aligned streets and efficient sewage and drainage systems. The quality of the buildings and the efficiency of the infrastructure left behind by the Romans are directly linked to the work of these visionary surveyors. The legacy of these land and map specialists not only ensured the growth and stability of the empire, but also inspired modern urban planning and cartography practices. Today, we can see the lasting effects of their work in maps, transportation systems, and even the structures we use to live and thrive. How did the legacy of Roman surveyors influence modern urban planning and civil engineering practices? What can we learn from their precision and territorial control for managing cities today? Roman roads were more than just simple transport routes. They were the vehicles that united the empire, connecting cities, armies, and merchants. From the early days of the Roman Republic, the Romans understood that the success of an empire was not only about military strength, but also about maintaining an efficient network of communication and transport. Roads became essential for the expansion and maintenance of the Roman Empire, allowing goods, troops, and information to flow rapidly and orderly throughout the empire. The design and construction of roads were impressive. The Romans used advanced techniques to ensure these roads were strong and durable. The paving process, which involved multiple layers of materials like stones, gravel, and sand, ensured the roads were well-drained and could withstand the weight of carts, carriages, and heavy troops. Roman roads were known for their stability and resistance to wear, allowing them to remain in use for centuries after their construction. One of the greatest advantages of these transport routes was their efficiency in connecting the empire. Merchants could transport goods such as wine, olive oil, grains, and textiles much faster and more securely. This strengthened the Roman economy as goods reached urban centers quickly, facilitating large-scale trade. Rome became a center of commerce and influence, fueled by the roads that connected its colonies, cities, and borders. Moreover, the roads also played a vital role in defending the empire. The Roman army could be moved quickly from one region to another to defend borders or suppress revolts. Control of the roads allowed the empire to regroup efficiently, making it difficult for enemies to invade or seize territory. Military roads were designed to facilitate the rapid movement of troops, creating direct and sturdy paths to ensure legions could reach any part of the empire in record time. The road network also helped maintain the empire's internal cohesion. Roman roads not only facilitated the movement of goods and soldiers, but they were also instruments of political and social control. They allowed the central government to maintain a strong, constant presence in the provinces, ensuring that orders from Rome were carried out efficiently, from the furthest borders to the central squares of the city. The roads also carried important symbolism. They represented Rome's order and power, and their carefully planned pavings, with distance markers and signaling systems, reflected the empire's superior organization. The roads, like Roman structures and buildings, showed that Rome was not just a military force, but also a civilization that understood the importance of infrastructure for its growth and maintenance. The legacy of Roman roads extended beyond their time. Their construction technology influenced not only medieval Europe, but also modern transportation structures. Paved roads became a model for the development of road systems worldwide, leaving an indelible mark on the way we build and organize our cities to this day. How did Roman roads become tools of control, trade, and defense? And how are these ideas still reflected in our current infrastructure? How can we apply the lessons from the Romans to organize our transportation networks and plan modern cities? When discussing Rome's military and commercial power, the Roman Navy played a crucial role, often overlooked in popular narratives. While the Roman legion is frequently considered the greatest fighting force of ancient Rome, its naval superiority was also one of the pillars that sustained the empire's expansion and security, allowing it to dominate the Mediterranean waters and protect its vital trade routes. In the early days of the Roman Republic, the navy was relatively underdeveloped, but over time, Rome came to understand the strategic importance of naval dominance. During the Punic Wars, in particular, the Roman navy was critical in the battle against Carthage, one of the empire's greatest rivals. To face them, Rome had to not only build a war fleet, but also innovate in naval engineering. In the famous Battle of Mylae, the Romans captured a Carthaginian ship and used it as a model to build their own fleet, adapting it to their needs and combat techniques. The main type of Roman warship was the trireme, a vessel with 3 rows of rowers, designed to be agile and fast on the water. These ships were equipped with beaks, large iron spikes, at the front, used to sink or destroy enemy vessels. Their advanced engineering allowed them to be maneuvered with precision, facing the challenges of naval combat on the open sea. But the true innovation lay in the design of the Roman fleets, which incorporated strategies of coordination and logistics to ensure supremacy at sea. Another essential component of Roman naval engineering was the construction of ports. Military and commercial ports were crucial for security and the flow of goods. Roman port engineering was incredibly advanced, using concrete structures and stone breakwaters to create deep and safe harbors. The port of Ostia, for example, was not only a point of arrival for goods, but also a military control center, from where the Roman fleet could be quickly deployed to any part of the empire. The Roman navy was not just about defense or naval domination. It also played an important role in the empire's trade, ensuring that Roman goods could be efficiently transported from one province to another. This strengthened the Roman economy by allowing Rome continuous access to precious materials like gold, silver, grains, spices, and Eastern luxuries, which were essential for the empire's wealth and expansion. Without a strong navy, Rome would not have been able to maintain control over its distant provinces or protect its vital trade routes, which were crucial for the empire's continuous growth. In addition to ship and port engineering, Rome also innovated in naval military organization. Roman fleet commanders were trained not only in combat tactics, but also in logistical strategies, ensuring that the ships were constantly supplied and maintained in fighting condition. For military campaigns, coordination between the navy and the army was essential, with warships serving as mobile platforms for Roman troops during invasions into enemy territory. Roman naval engineering left a legacy that lasted for centuries, influencing ship designs and naval strategies of later civilizations, such as the Byzantine Empire and other medieval powers. Today, we can trace the foundations of modern naval engineering back to those Roman innovations that turned the Mediterranean into the Roman lake, ensuring the empire's expansion and control over one of the greatest civilizations in history. How did the Romans manage to transform the Roman navy into a global power, and what impact did their naval engineering have on controlling trade routes and military expansion? What can we learn from how ancient Rome integrated ships, ports, and warfare to sustain its dominance? In the vastness of the Roman Empire, ports were more than simple points of arrival for ships. They were bustling hubs connecting Rome to a distant and diverse world. The port of Ostia, located at the mouth of the Tiber River, became the primary entry point for goods that supplied the city of Rome and the empire as a whole. It was here that the riches of the Mediterranean world were unloaded, and the trade that sustained Roman power took shape. The construction of the port of Ostia was an impressive milestone in Roman engineering. The Romans, known for their ability to adapt and innovate in their constructions, created a port with state-of-the-art infrastructure for the time. Concrete structures and stone breakwaters were used to ensure the port was deep enough to accommodate large vessels. With docks and warehouses strategically positioned, Ostia became a major distribution hub, where products like grains from Africa, spices from Asia, and wine from Gaul were brought together to be redistributed throughout the empire. The port of Ostia, however, was more than just a trading hub. Its strategic location on the Tiber River allowed it to also serve as an important military base. During wartime, Ostia became a crucial point for the Roman navy, facilitating the rapid resupply of troops and enabling Rome to maintain a strong naval presence in the Mediterranean. Its advanced defenses, including watchtowers and coastal fortifications, ensured that trade continued uninterrupted even in the face of potential threats. Another key port in Roman history was the port of Julius, located in the region of Ptolemais. This port was a major engineering project conceived by Emperor Julius Caesar himself, whose aim was to create a direct route between Rome and Egypt, one of the empire's largest grain suppliers. With highly sophisticated facilities, the port of Julius stood out for its efficiency in cargo handling and the construction of anchorage infrastructure to accommodate different types of vessels. The impact of these ports on Rome's economic dynamics was undeniable. They not only allowed for the continuous supply of essential products to the city, but also boosted international trade, making Rome the center of a global empire. Trade was not just a means to enrich the Roman elite, but also a way to consolidate Roman power and influence over other regions of the known world. Moreover, the port of Ostia and other ports like Julius were symbols of Rome's urban planning. Roman engineers did not just build for function, but also considered the visual and symbolic impact of their structures. Monumental entrances, windmills used to facilitate cargo loading and unloading, and vast docks were clear representations of Rome's majesty and control over the waters and lands surrounding it. Today, when we observe the strategic importance of these ports, we can see how Roman engineering in the naval field was crucial to the city's growth and the empire's expansion. Roman ports, with their logistical systems and advanced infrastructures, serve as the foundation for understanding the relationship between trade, power, and territorial control that defined Rome as the dominant power of the ancient world. How did the Romans manage to turn the ports of Ostia and Julius into vital elements for their economy and security? What was the impact of their innovations in managing trade routes and controlling the Mediterranean? As the Roman Empire expanded, and its legions marched through distant lands, Roman bridges became a symbol of the power and extraordinary engineering of ancient Rome. These imposing structures were not just practical solutions to overcome rivers and valleys, but represented the Romans' dominance over nature and their ability to transform the environment around them to facilitate the empire's expansion and conquest. Roman innovation in bridge construction was unparalleled in ancient history. They used advanced architectural and engineering techniques that allowed them to create durable and resilient bridges. Instead of simple wooden or stone crossings, the Romans developed stone bridges, many of which remain standing today, more than 2,000 years after they were built. The key to this durability was the use of arches, a Roman invention that revolutionized architecture and engineering. By using arches, the Romans were able to distribute the weight of the structures more efficiently, allowing them to build larger, stronger, and more stable bridges than anything seen before. The Trajan Bridge, for example, which spanned the Danube River in modern Romania, is a clear example of the magnitude and sophistication of Roman engineering. This bridge was not only a practical solution for crossing Roman troops and goods, but also a monumental landmark showcasing the power and glory of Rome. With a length of more than 150 meters and a height of 6 meters, the Trajan Bridge represented an impressive feat of engineering for its time and symbolized Roman conquest and control over the regions that were now part of the empire. But Roman bridges were not only grand and durable constructions. They also had an essential functional and strategic role in maintaining and expanding the empire. When the Roman army marched through new territories, bridges facilitated the quick movement of legions, allowing the Romans to move efficiently to defend borders or subjugate new provinces. Furthermore, bridges were vitally important for trade and communication within the empire, creating an uninterrupted network of roads that connected Rome to all its provinces, promoting unprecedented economic and cultural integration. However, Roman bridge engineering was not limited to structural durability. Roman engineers were also masters of aesthetics and design. Roman bridges were often adorned with artistic details and inscriptions that celebrated the Roman conquest or administration of certain territories. These inscriptions not only recorded historical events, but also reinforced the idea that Rome was a dominant force, capable of transforming the natural environment and creating an interconnected and organized world. Another classic example of Roman engineering in bridges was the Tiber River Bridge in Rome, which connected different areas of the city and allowed for the rapid transport of goods and movement of Roman troops. Throughout the empire, other iconic bridges, such as the Aqua Claudia Bridge, served as vital connectors between cities, villages, and commercial centers, consolidating the unity of the empire. To this day, many of these Roman bridges stand as living testaments to the legacy of Roman engineering. Not only have they stood the test of time, but they also influenced modern architecture and bridge construction techniques worldwide. The combination of technological innovation and monumental aesthetics made Roman bridges one of the most enduring landmarks of their civilization. Through these grand structures, Rome overcame nature and created an empire that not only existed but expanded and interconnected in an unbeatable way. What more can we learn from the way the Romans designed their bridges? How do their innovations influence modern bridge construction? In the dynamics of Roman warfare, the need for flexibility and speed on the battlefield was essential. The temporary and floating bridges built by the Romans were the ultimate solution to allow their legions to cross rivers and other natural obstacles quickly and effectively, without wasting time or resources on permanent constructions. These bridges were not only ingenious, but also impressively functional. The Romans developed a system of floating bridges that could be assembled and disassembled with remarkable agility. Using rafts and floating wood, they created a secure crossing over wide and turbulent rivers, turning a potential natural disadvantage into a strategic advantage. The most famous example of this type of construction occurred during Julius Caesar's campaign against the Germanic tribes along the Rhine River. To cross the river, Caesar and his troops built a floating bridge in a matter of days. The bridges, made from logs and tied together with ropes, were light and quick to build, allowing soldiers and cavalry to move without relying on pre-existing locations. More than just a crossing, these bridges conveyed a powerful message. The Romans would not be stopped by anything, not even the forces of nature. When the Germanic tribes prepared to face the Roman advance, rivers were often considered a natural shield. But for the Romans, an obstacle was just another challenging opportunity. The creation of improvised bridges showed the skill and adaptability of the Roman army, always ready to meet any challenge. The speed with which the bridges were built ensured that Roman troops could move faster and with more flexibility than any enemy attempting to confront Rome's military might. Another striking example of temporary bridges occurred during Trajan's conquest of Dacia. To cross the region's turbulent rivers, Roman military engineers built bridges that could be easily dismantled but were incredibly strong while in use. This approach, in addition to ensuring military mobility, also reinforced Rome's image as a force capable of overcoming any difficulty. While floating bridges were a quick solution, Roman engineering also applied other types of temporary bridges. On some occasions, wooden bridges were assembled in record time to ensure the transport of soldiers and supplies. These bridges were often dismantled after crossing, leaving little to no trace of the infrastructure that had once supported the army. In addition to efficiency, the design of Roman bridges reflected a deep understanding of topography and hydrology. Roman engineers were skilled at choosing the best locations for construction, ensuring that floating or temporary bridges were not only quick to build, but also stable and safe for soldiers and the war machines accompanying them. These temporary and floating bridges, despite their ephemeral nature, played a vital role in ensuring the effectiveness and mobility of the Roman legions. They represented the flexibility of Roman strategies, which could be adapted to any situation without compromising efficiency or speed. What can we learn from the Romans' ability to adapt their engineering to meet military needs? And how did floating bridges influence the way the Roman Empire was able to conquer and maintain its territories? The Roman Empire was not only known for its military strength, but also for the extraordinary infrastructure network that supported its vast dominion. One of the greatest feats of this monumental engineering was the Roman roads, built with the expertise and precision of an army of specialized engineers. These road engineers, like an elite group within the Roman machinery, were responsible for constructing and maintaining the roads that connected cities, provinces, and borders, facilitating military mobility, trade, and administration throughout the empire. Unlike simple dirt paths, Roman roads were true examples of engineering. Each road was meticulously planned, built with multiple layers of materials, such as stones, sand, and concrete, and designed to withstand the wear and tear of time and weather. But the skill of Roman engineers wasn't limited to the quality of the materials. They applied an impeccable drainage system to ensure that the roads didn't become flooded or damaged by heavy rains. This focus on drainage was one of the secrets to the durability of these roads. Roman engineers were masters of paving. Using a technique that involved placing multiple layers of materials, they created a solid and uniform surface for traffic. The top layer, made of polished stones, ensured that vehicles and soldiers could march with ease, while the lower layers provided stability and strength. The precision in the curvature and leveling of the roads was also crucial, as it ensured safe and quick travel, and made it easier for troops to move across difficult terrain. These roads were not only functional, but also a testament to Rome's grandeur. Along their roads, the Romans erected milestones and signaling systems that not only guided travelers, but also served to show the empire's presence in every corner of the known world. Each road represented a central nerve connecting various cities and provinces, allowing the flow of goods, information, and military forces. Roman roads, therefore, were more than just transport routes. They were the lifeblood that allowed the imperial machine to run smoothly. A soldier could march from Rome to the farthest borders of the empire. A merchant could transport goods from one province to another, and a governor could travel quickly from one city to another, all thanks to the efficiency and intelligence behind Roman roads. The greatness of Roman road infrastructure wasn't limited to the grand avenues of the city. Secondary roads, often used to connect smaller cities, also followed the same construction standard, demonstrating the Romans' commitment to creating a cohesive and integrated network throughout the empire. Behind these constructions was the skill of the military engineers, known for their precision and expertise. When the Roman legions marched into new lands, these construction specialists marched along, ensuring that while the troops conquered and defended territories, infrastructure was being constantly created and expanded. These roads were a vital element for Rome's progress, and in fact, the rapid movement of troops, enabled by these roads, was one of the greatest factors contributing to the empire's military success. The Roman roads continue to be one of the greatest legacies of Roman engineering. Not only did they connect the empire in ways never seen before, but they also profoundly influenced the development of modern infrastructure, with many of the ancient paths still in use today. What more can we learn about the organization and strategic vision of the Romans through the creation of their roads? In ancient Rome, the grandeur of its cities wasn't limited to monumental architecture and impeccable streets. Roman engineering reached impressive levels in water management and sanitation infrastructure as well. One of the greatest landmarks of this ingenuity was the Cloaca Maxima, a drainage system that not only protected the cities from flooding, but also helped maintain public health on a scale that at the time seemed almost futuristic. The Cloaca Maxima, initially built in the 6th century BC, was one of the world's first and most advanced sewage networks. Its name, which can be translated as Great Sewer, says much about its importance. The idea behind this system wasn't just to eliminate waste, but also to control rainwater and ensure that the city wouldn't be affected by floods. The Roman engineers were able to design a system that collected rainwater from the streets and directed it out of the city efficiently and safely. But the Cloaca Maxima was just the tip of the iceberg. As Rome expanded, new drainage systems were created to meet the growing needs of a constantly developing city. The streets were planned so that water would naturally flow into the sewers, and in many cases, basins were built to facilitate drainage. This network wasn't just efficient, but also a clear example of Roman organization and intelligence in turning a simple water management problem into a solution that would shape the future of cities. Beyond ensuring water drainage, the Roman sanitation system also reflected a concern for public health. The presence of underground sewers, away from residential and commercial areas, helped prevent contagious diseases, which were common in densely populated cities. The combination of drainage systems and wastewater helped avoid the accumulation of organic waste in the streets and residential areas, limiting contact with contaminated water. Another fascinating aspect of Roman drainage engineering was the regularity and maintenance of the systems. Roman engineers, many of them hydraulic specialists, had teams dedicated to inspecting pipes and channels to ensure nothing was blocked. And when a Roman was assigned to manage a drainage or sanitation system, they were responsible for ensuring that everything operated precisely so that no part of the city would suffer. Retention basins, built along various parts of Rome, also helped regulate water flow, preventing heavy rains from damaging the infrastructure. This water control not only prevented flooding, but also ensured that urban areas remained dry and accessible throughout the year. Regular cleaning of these basins was also crucial, and the Romans had specific methods for removing waste without harming the city. As Rome expanded, the concept of efficient urban drainage was adopted in its colonies and conquered cities, allowing the empire to maintain sanitary control throughout its vast territory. Roman technology was so advanced that many of these drainage systems still exist in ruins, but their construction and long-term impact on modern urban planning are undeniable. It's no wonder many scholars argue that Roman drainage engineering was one of the factors that allowed the city of Rome to remain and grow for so long. The legacy of the Cloaca Maxima and the Roman drainage systems goes beyond practicality. It teaches us about the Romans' long-term vision and their ability to plan ahead to ensure the sustainability of large cities. How did Rome's solutions to urban problems influence advancements in drainage in modern cities? What can we learn from Rome's commitment to public health and the well-being of its citizens? The Roman legions were unbeatable, not only because of their discipline and combat strength, but also due to their ability to adapt and build military infrastructures. When the Romans marched to the frontiers of the empire or prepared for long-term campaigns, their military engineers were indispensable. One of the greatest innovations in this field was the construction of fortified camps, which were not only places of rest for the troops, but also temporary fortresses with impressive engineering. Each Roman camp, known as castra, was designed with meticulous strategy, ensuring the protection and efficiency of the military forces. These camps were set up in a few days, thanks to the skills and preparation of the military engineers. As soon as the troops arrived at the chosen site, coordinated work began. Defensive walls, trenches, watchtowers, and entrance gates were erected quickly and effectively to create a secure fortress for the soldiers. The construction of Roman fortified camps followed a standardized model, reflecting the level of organization and discipline that characterized the legions. Each camp had an organized structure, with specific areas for troops, animals, supplies, and even for senior officers. The internal street network and the arrangement of tents within the camp were planned to optimize both logistics and defense. The wall surrounding the camp was the main line of defense. Made of wood or, in some cases, stone and earth, the wall was designed to be high enough to prevent any surprise attack, but also adaptable for emergency situations. Trenches were dug around the wall to make it difficult for enemies to approach, and the entrance was protected by fortified gates, controlled by sentries and guards. The work of Roman military engineers wasn't limited to constructing external fortifications. They also designed internal structures that ensured the efficiency and comfort of the troops. For example, there were drainage systems to prevent rainwater from flooding the camp, food storage areas, and even structures for religious ceremonies, which were essential for troop morale. Everything was planned with precision to ensure that the camp was not only secure, but also functional for days, weeks, or even months. The great skill of Roman engineering was realizing that defense and mobility were equally essential. These fortified camps were built to be quick to assemble and easy to dismantle, allowing the troops to move rapidly without compromising security. Thus, even in urgent or pressured situations, the Romans could retreat or reorganize quickly without losing their military strategy. This level of preparation and professionalism made the Roman legions stand out for their mobility and ability to sustain prolonged campaigns, even in hostile territories. The ability to build fortified camps allowed the Roman forces to establish operational bases in unfamiliar terrain, reinforcing Roman influence and keeping enemies under constant surveillance. The military engineers were also responsible for coordinating the resources necessary for these constructions. Materials such as wood, stone, and tools were transported by the legions or acquired locally, depending on the circumstances. The ability to improvise and adapt materials according to the terrain was one of the most impressive skills of the Romans. Throughout its history, Rome was able to expand its borders and maintain a vast empire, in part due to military engineering and the ability to construct these temporary fortifications. The Roman camp, therefore, was not just a resting place, but a strategic masterpiece that combined engineering with militarization, ensuring the survival and success of Rome in military campaigns across the empire. In the relentless quest for domination and expansion of the Roman Empire, military engineering was not limited to the construction of camps or fortifications, but also extended to the development of complex and innovative war machines. These machines were one of the cornerstones of Roman military power, helping to conquer distant territories and secure victories in crucial battles. Among the most notable were the catapults, ballistae, and onagers, which redefined the way war was fought. The Roman catapult, one of the greatest feats of military engineering, was designed to launch large stones or heavy projectiles over long distances, causing destruction in enemy ranks or fortifications. These throwing machines were operated by torsion systems, using the force of ropes and springs to accumulate energy and fire the projectiles with impressive accuracy. The range of catapults varied, but they were capable of launching heavy stones up to 300 meters, making them decisive in siege battles. Another notable Roman war machine was the ballista, which operated similarly to the catapult, but with a more robust design and the ability to shoot giant arrows or metal projectiles. Its main advantage was accuracy. Unlike catapults, which were more focused on launching large stones, the ballista was ideal for attacking enemy troops from a distance with great precision. Its firepower proved essential on open battlefields, where the legions could strike from afar before the enemy had a chance to approach. However, Roman machines were not limited to just these two. The onager, a more advanced and powerful version of the catapult, was developed to launch larger and heavier projectiles, such as stones and even large pieces of metal. The name onager, meaning wild donkey, referred to the impact strength of the machine, which was capable of destroying fortifications and causing significant damage to enemy lines. This type of catapult was often used during sieges, where destroying enemy defenses was crucial for Roman victory. Roman war machines were not only used for long-range attacks, but also served as essential tools for destroying fortifications during military campaigns. When the legions encountered enemy city walls, it was crucial that their war machines could break or weaken the defenses efficiently. Thus, Roman military engineers created devices like siege towers and battering rams to breach the walls and knock down gates. These machines required exceptional engineering skills, but also specific training. Military engineering teams consisted of specialists who knew how to assemble and operate these machines effectively in combat situations. The process of building these machines was not simple and involved using high-quality materials, such as durable wood and specially braided ropes to ensure the machines were both sturdy and powerful. In addition to their effectiveness in battle, these machines also played a significant symbolic role. The presence of a catapult or ballista on the battlefield not only represented Rome's military power, but also served as a psychological warning to the enemy that Rome's technological superiority was unquestionable. Enemies facing the Roman legions could feel intimidated by the impressive destructive force these machines could unleash, and this fear turned into a strategic advantage for Rome. Roman military engineering influenced not only its territorial expansion campaigns, but also the lasting military legacy that persists today. The ideas and principles used in Roman war machines inspired the development of new military technologies in several subsequent civilizations. For this reason, Roman war machines remain one of the greatest legacies of Roman engineering and military strategy, demonstrating once again how engineering and the art of war were inseparable in the building of the empire. The grandeur of the Roman Empire was not defined solely by its powerful military machine or its administrative organization. One of the most impressive legacies of Rome was its monumental architecture, which reflected the power and culture of a civilization in constant expansion. Roman architects, with their innovative vision, created works that not only served functional purposes, but also became eternal symbols of Rome's magnificence. Over the centuries, Roman architects were responsible for some of the most imposing constructions of the ancient world. From grand temples dedicated to the gods to public squares, baths, forums, and amphitheaters, each structure was a masterpiece of engineering and aesthetics. The Romans had an extraordinary ability to plan and build spaces that met the practical needs of the empire, but they were also deeply symbolic. One of the greatest examples of this architectural feat is the Colosseum, the massive amphitheater that became a symbol of Rome itself. Its concrete and stone structure was innovative for its time, using arches and columns to create a building that could accommodate up to 50,000 spectators. The Colosseum was not just a place for spectacular events like gladiator combats and wild animal hunts. It also represented Rome's power and its ability to build spaces that brought the people together and celebrated the grandeur of the empire. Roman architects were able to plan its construction so that it was not only resilient and functional, but visually impressive. Another great example of the skills of Roman architects is the Roman baths, gigantic complexes that combined public bathing with heating systems and leisure facilities. The baths of Caracalla, for example, could accommodate up to 1,600 people at once. These buildings were not just places for personal hygiene. They were social and cultural hubs where Romans of all social classes could meet, converse, and relax. The heating and drainage techniques were truly advanced, with underground systems that kept the water heated consistently. Every element of the construction was planned to ensure comfort, while also reflecting the wealth and power of the empire. Public squares and forums were also architectural works of great importance. The Roman Forum, located at the heart of the city, was the center of Rome's political, social, and religious life. In these spaces, architects not only created areas for political assemblies, but also built temples, public benches, and markets, all designed with perfect proportions and using symmetry techniques that represented the order and efficiency of the empire. Each square or forum had a specific design that reflected the function for which it was created, but they all had one thing in common: they were impressive and functional. Roman innovation in materials was also a crucial factor in the success of their grand constructions. The use of concrete was a revolution in architecture, allowing for the creation of more complex and durable structures. Instead of relying solely on stone, as the Greeks did, the Romans began using concrete, which was cheaper and easier to manipulate. This enabled the creation of bolder forms and new building techniques, such as arches and domes, which became trademarks of Roman architecture. The Pantheon in Rome, with its massive concrete dome and central opening, the oculus, is a perfect example of how Roman architects managed to balance functionality, beauty, and innovation. The Pantheon's dome was the largest in the world for centuries and remains one of the most impressive concrete constructions ever made. Originally dedicated to the Roman gods, its construction stands as a testament to the Romans' ability to create sacred and functional spaces designed to reflect the grandeur of the empire. In addition to public constructions, the Romans also created impressive private residences, such as the domus and the villi. These homes, often with gardens, inner courtyards, and pools, were symbols of wealth and status. Roman architects were masters in creating elegant and luxurious spaces that were still practical and suitable for the daily needs of the wealthier Romans. Throughout the Roman Empire, architects played a key role not only in building physical structures, but also in creating spaces that represented the ideas of order, power, and culture of the empire. Roman architecture was not just functional, it was also a reflection of the empire, an advanced, organized civilization filled with great achievements. In the vastness of the Roman Empire, where great buildings and architectural innovations flourished, one name stood out above the rest: Vitruvius, the man who would be remembered as the father of Roman architecture. His work not only influenced the architecture of his time, but also shaped the foundations of Western architecture for centuries. What made Vitruvius such a remarkable figure was his ability to merge theory and practice, creating principles and formulas that governed the design and construction of buildings for generations. Vitruvius was born during a time of great transformations, around the end of the 1st century BC. He was a military engineer, but his vision extended beyond military needs, which led him to become a writer and theorist. The work that immortalized him was his treatise, De Architectura, a collection of 10 volumes exploring every aspect of architecture, from human proportion to space distribution. His work was an attempt to systematize the art of construction, giving it a solid foundation of universal principles that are still studied today. Vitruvius' legacy rests mainly on 3 fundamental principles that he believed were essential for any architectural work: firmitas, strength; utilitas, usefulness; and venustas, beauty. For him, a building should be strong, withstand time and elements; functional, perfectly serving the needs of those who would use it; and of course, beautiful, reflecting the harmony and order at the heart of Roman culture. These ideas became the foundation not only of Roman architecture, but also of the Renaissance, when artists and architects looked to Vitruvius for inspiration. The concept of proportion was one of Vitruvius' most significant innovations. He believed that architecture should mimic the proportions of nature, an idea closely linked to the Vitruvian Man, Leonardo da Vinci's famous drawing. Vitruvius suggested that buildings should follow perfect geometric proportions, with the relationship between height, width, and depth designed to reflect natural harmony. He studied the proportions of the human body and suggested that a good building should reflect the same proportions as the human body, with the human form at the center of design and functionality. Moreover, Vitruvius was also responsible for some of the first discussions on choosing materials for construction. He identified different types of stone, wood, and building materials, offering guidelines on where and how each should be used, depending on the structural need and aesthetic of the project. He also discussed the importance of the building's location, suggesting that a good architect should always study the terrain and local climate to ensure the durability of structures. His influence was immense. Vitruvius' work was widely cited by Renaissance architects such as Leonardo da Vinci, Michelangelo, and Andrea Palladio, who encountered the treatise during the Renaissance and adopted it as a guide. Even after centuries, Vitruvius' impact was felt throughout Western architecture, with his principles still being taught in architecture schools worldwide. But Vitruvius' true genius lay in how he connected the arts and science. He not only taught about the physical act of building, but also provided architects with a philosophy for living and creating. His works were a blend of art, mathematics, and engineering, something that transcended the mere construction of buildings and became a form of cultural expression. Looking at the great constructions of Rome, such as the Pantheon or the Colosseum, we see the application of Vitruvian principles in action. Every arch, every column, and every design space was not just an aesthetic or functional choice, but an expression of the harmony that Vitruvius defended as essential for any great work of architecture. His vision lived on, being adapted and applied through the ages, and his ideas still reverberate in modern buildings. In summary, Vitruvius was not just a theorist, but a visionary who united engineering and art in a unique way. His work not only shaped Roman architecture, but also helped shape the architecture of the future, influencing generations and ensuring that Roman wisdom would endure for millennia. His masterpiece is a testament to the innovation and intellectual brilliance of one of the greatest periods in human history. Roman engineers were masters in the art of turning the impossible into reality. Their creations, which began with a simple concept of functional building, evolved into engineering marvels that defy the limits of time. As Rome expanded and transformed into a global empire, Roman engineers were instrumental in ensuring that its cities, military structures, and infrastructures operated with efficiency and effectiveness. But what is truly impressive is that many of their techniques and innovations still influence the modern world. These engineers were not just builders. They were visionaries who saw more than just the construction of roads, aqueducts, or bridges. They understood the science behind each stone laid, each calculation made, and each material chosen. Over the centuries, their ideas became the foundation for many of the modern infrastructures we use today. One of the greatest contributions of Roman engineers was their innovation in material use. While the Egyptians and Greeks were also masters in construction, it was the Romans who perfected the mixture of concrete, creating a material that was not only more durable, but also allowed for innovative forms of construction. Roman concrete, like that used in the Pantheon's construction, became the backbone of their greatest works and enabled the creation of open spaces and large domes that were once unimaginable. This special concrete, known as opus cementitium, not only withstood the test of time, but also directly influenced contemporary architecture. Roman roads, another great feat of Roman engineering, were not just transportation routes. They were meticulously planned structures, with layers of materials that ensured long durability and resistance to the elements. Over time, these roads became the backbone of the empire's expansion, allowing for efficient movement of the army and trade. The road system not only connected cities in the empire, but also served as a model for modern road systems. Even today, traces of these ancient Roman roads can be found, a testament to the durability and intelligence of Roman engineering. Another key legacy is the aqueduct system. Roman engineers created an impressive hydraulic infrastructure capable of transporting large volumes of water from distant sources to the cities. The construction of these aqueducts required a deep understanding of hydraulics, geometry, and structural engineering. Elevated arches and underwater tunnels allowed Rome and other Roman cities to have a constant water supply, which made it possible to build public baths, fountains, gardens, and even sanitation systems. Moreover, the Roman military strategy also relied on the work of specialized engineers. They were essential in building fortifications, walls, and temporary military camps. The famous Hadrian's Wall is just one example of how Roman engineers used their skills to defend the empire's borders. These fortresses were not just physical barriers, but also symbols of Roman power. The long-term vision of Roman engineers is also evident in their ports and naval infrastructure. Innovations in the ports of Ostia and Puteoli ensured that Rome could maintain its supremacy in maritime trade and naval defense. Roman naval engineering was a crucial component for territorial expansion and dominance in the Mediterranean, with the construction of ships like triremes and quinquiremes, and the creation of strategic ports that ensured supply and communication routes. Over time, the legacy of Roman engineers was passed on to other cultures, especially during the Renaissance, when architects and engineers began to revive their ideas and techniques. The work of Vitruvius, for example, served as a manual for subsequent generations of architects and engineers. His ideas on proportion, symmetry, and functionality were not only preserved but also improved, inspiring the creation of grand buildings and cities in Europe. Today, the impact of Roman engineering is still visible, whether in the grand public works of various cities, modern roads, or the construction techniques we use. The study of Roman engineering continues to be a source of inspiration and learning, showing us that the past is never truly lost, but rather present in the foundations of our own future. So, what did you think of this incredible journey through Roman engineering? It's amazing how the techniques of the ancient Romans continue to influence the world today, right? If you liked the video, don't forget to leave a like, as it really helps the channel grow and bring more quality content to you. If you have any questions or want to share your opinion on the legacy of Roman engineering, leave a comment below. And of course, if you haven't subscribed yet, make sure to subscribe to the channel and hit the bell so you don't miss the upcoming videos about the fascinating world of ancient Rome. See you next time.